So in this video, we're going to first download the dataset. I have downloaded the dataset from this challenge called RSNA Pneumonia Detection Challenge, and it was done on November 2018. Okay, so you can download the dataset from here. You can see a data tab. If you come below, then you can see download all. Over here, we have the train labels as well as the images of our dataset that we need. Okay, the images that we can find over here are all DICOM files. Okay, to read this kind of files, we need a library called Pydicom. Okay, so we will see how we can do that later. I have already downloaded it and I have put it in one folder called YouTube. Okay, so over here we are doing nothing but just mounting our Google Drive with our Google Colab. Okay, after that we are cding into our YouTube folder, YouTube directory, where we have our data stored. If you ls in this folder, then you can see that there are data, models, as well as pneumonia classification. This notebook over here is inside this folder, pneumonia classification. So we can just, rename it to preprocessing. Inside the data folder, we have one zip file, which is the zip file that we have downloaded from this Kaggle dataset. Okay, so now we have to unzip this file, and to unzip it, we are going to use this command. We are already inside the YouTube directory. We have to get inside this data directory. After that, we can just take this file. So zip file, and we'll put it inside /content. Okay, so that it does not take up a lot of memory inside our Google Drive. Okay, so once we do that, we'll have to wait a bit. So I have already fast forwarded this video. You can see the unzipped files are over here inside our content directory. So let's understand this command. This is the unzip. We are saying unzip this zip file. Where should we unzip it? In this directory. Because it is a directory, so we are giving it a flag called -d. So the things we need are the CSV as well as the train images folder. We need to first import few libraries. So let's import pathlib, Pydicom. Then we should import NumPy as np. Then we should import CV2. Okay. Then we should import pandas as pd. Then we can also import matplotlib, plotlib.pyplot as plt. Import, not import. At the end of the day, we'll import tqdm. Import tqdm. Okay. So over here you can see the Pydicom library has one line. So the Google Colab does not provide Pydicom library by default. Okay, so you have to install it first. So let's install it. So we can just say pip install Pydicom. Okay. After that, once we are done with this, now we can import all these files. Okay. The first thing we will do after importing, we will read the CSV file. Let's copy this path. And we can just say labels underscore CSV equals to pd.read CSV. Okay. And after that, we can just print the head. There are a few things that you can see over here. The first one is the patient ID. All the images are this ID followed by the DICOM extension, the DCM extension. Okay. After that, you can see the bounding boxes, X, Y, width and height. We will not use that because we are not doing detection. We are just doing the classification part. After that, we will see the target, whether this X-ray has pneumonia or it is a normal X-ray. Let's take the labels.csv and let's see if there are any duplicate values for the patient. So we can do value underscore count. So you can see over here, there are few patient IDs which are repeated. Okay, so this patient ID has 4 instances, this patient ID has 4 instances. Okay, so you need to at first remove all these duplicate rows. Okay, so what we can do, we can just say labels underscore CSV equals to label CSV dot drop duplicates, and after that we can just enter the patient ID. Okay, yes, I'm going to copy and paste because I am lazy. Okay, now let's see whether it has been done or not. Yes, so you can see over here the duplicate values has been removed and all the values in this data frame only has one instance. Okay, So now what we have to do, we have to go into this train images folder. Inside the train images folder, we have to fetch the file with this name. If the target value is 0, then we have to put the file in some folder called normal. If the target value is 1, then we have to put that file inside some folder called pneumonia. Okay, so you can see over here the file names, and it is followed by the extension of DCM. Okay, so now to do that, first we need to go into this folder. So we'll just copy the path of this folder and we will create a path called root path. Okay, in this root path, we will put the path that we have just copied. Okay, so this path. Now let's check this for one single image. Okay, so let's just check for file name. This file name will be the name of the file. Let's take this and take the first image as the file name. This file name that we have taken from the CSV file does not have DICOM or DCM extension at the end. Okay, we will do it like this. Okay, so we'll create another variable called file path. So we will say root dot join path file name, the file name that we have taken, file name. So here will be underscore in between. Now that we have the path, we have to read the image. Okay, so to read the image, what we need is the Pydicom library that we have installed. Okay, we cannot read the Pydicom files like we read the JPEG files or the NumPy files. Okay, so let's read the Pydicom file. Let's create a variable called DCM file, and over here we can say Pydicom dot read file. Okay, inside here we can give the path. Now let's print the DICOM file and see what is inside it. Okay, there are a lot of information that is inside this DICOM file. Okay, so over here you can see the patient ID, you can see the patient's birth date, the patient's sex, patient's age, the body part that was examined. So a lot of details are present over here. Okay, so over here you can see there is one field called pixel data. We can use these to get our images. Let's see how we can do that. So to get the pixel data, we need to first take the DCM file and we need to take the pixel array. Okay, now if we do the pixel array.shape, then you will see that our value is 1024 and 1024. This is a grayscale image. Okay, so we can plot this image with matplotlib. So let's see what we will have. So plt.imshow, and at the end we can say cmap equal to gray. This is our extra image. Okay, now let's do one thing. We have already seen that in our level CSV there is one column called target. Okay, let's see whether this data is imbalanced or balanced. If the number of positive classes and the negative classes are same, then we call the dataset as balanced dataset. But if the data is imbalanced, then that means the frequency of one class will be significantly more than the other class. Okay, so let's see whether that is the case over here or not. Okay, so we can just take labels CSV, take the target, and we can do the value count. So over here you can see there are much more normal classes, like 3 times than the positive classes, the pneumonia class. Okay, so we will see how we can tackle this problem later when we will be creating the model. But for now, just remember this kind of issue can arise when you are dealing with like medical data set a lot. Now let's copy paste the code so that we can plot our images with labels. So over here we are defining 2 variables, fig and axis. We are calling the subplots method from the matplotlib, which will plot 6 images. Each image will have size of 10 cross 10. After that we are defining another variable called count, which we will increment at the end of the inner loop. Then we define 2 loops, the first loop which will iterate over the rows and the second loop which will iterate over the columns. Same as before, we take the patient ID. Instead of just giving it an index, we are using iloc. With this, we will get each row's patient ID. Okay. After that, we are doing the same thing for the target variables. Then we will join the root path with our patient ID and we will add the suffix DCM at the end of the file. Then we will read our Pydicom file and we will take the pixel array from it, the way we did over here. Now, if the target is 1, then we are saying make the label as pneumonia. If it is 0, then make it as normal. So else normal. Okay, now we are just plotting our images with the title as the label that we have set, which will be either pneumonia or normal. Then we are incrementing the count variables. Let's see. Over here, you can see there are like normal, 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 normal. This is the one pneumonia class that we have got. Now it's time for preprocessing. After we preprocess the images, we need to store those images at a certain location, at a certain directory. So we will name it output folder. The path of that output folder will be /content/preprocessed. So now let's create the loop, and to create the loop, we will use iterRows method in pandas. Okay, this iterRows method will give the index as well as the row in label_csv dot iter. Okay, and we will put this into tqdm so that we can see how much is done. We'll create the file name and we will take it from the row. Let's also extract the target variable, row target. After that, we need to change these target values from 0 to 1 to normal and pneumonia. Okay, so to do that, we have already done the code over here. We will just use this. And to read the file, we have already done that code as well. So we will take from here to here. Okay. Ident it properly. This file path, we are taking the root path and joining with patient ID. Instead of patient ID, it should be file name. And we are adding the suffix DCM at the end. So instead of calling it file, let's call it array, DICOM array. Okay. Now, once we do that, we need to divide each pixel of this Pydicom file so that we can normalize it, so that it ranges between 0 to 1. Why 255? Because the range of this Pydicom file is between 0 to 255. So if we divide it by 255, the range will become from 0 to 1. Okay. So to divide it, we'll just do divide 255. That's it. Now this DICOM array is in the size of 1024 cross 1024, and we need to resize it so that we can feed it into the neural network. Okay, so we will resize it, image resized, and we will use cv2 to resize it. So cv2.resize method, and we will just pass the DICOM array, and we will resize it into 224, 224. Why 224, 224? Because we will train a model called efficient net. And the efficient net takes this image dimension. That's why we are resizing it into 224, 224. Okay. Now we are done with preprocessing. Now we just have to save it. So to save it, we can just call output path. Let's call it class. Okay. Because we are going to save each image based on their classes. Let's remove this one. Folder / the label, like it will go into the preprocessed folder. Inside there, it will go into the pneumonia or the normal folder to save each file in there. Okay. Okay. So make directory, we are saying parents equal to true, which means if the parent directory does not exist, then create the parent directory as well. Exist. Okay. Equals to true. After that, we will just save this image underscore resized as NumPy array. We'll just say output path class, and we will save it as file name. We'll save the image resized. Let's run this code. Okay, so I have fast forwarded this video and we are done. It took almost 6 minutes. Okay, now let's see inside our content folder. Yes, we have preprocessed folder. Inside that there is normal as well as pneumonia. Okay, now let's see how many NumPy files are there inside the normal folder as well as in the pneumonia folder. Okay, so for that we can use import os, and we can just do os.list dir. Same thing, but normal. Okay, but this will give you an array. You can just put it inside length and it will give you back the exact number. Okay. Let's see. 6012 20672. Okay. Okay, so we can see that our code has worked. In the next video, we will train an efficient net model using this dataset.